The diagram below shows the triangle XYZ. Construct a bisector of the angle XYZ using only a compass and a straight edge. Show all your construction lines and arcs. Hence construct the incenter of the triangle XYZ below. Okay, so I'm not going to be able to do this, but I have done a video on this. If you want to have a look on my website or on the YouTube channel, you can find the constructions for an incenter and other constructions as well. But I'll just generally do this freehand, show you generally what needs to be done. You need to get your compass, put it, what angle do we need to bisect first? XYZ. So we need to bisect this angle down here first. So what you're going to do is you're going to put the compass here first. You're going to draw an arc here, let's say, and another arc here. You're then going to just identify those points there, put a point there and a point there. You're going to then put your compass here, and what you're going to do then is draw another arc out here from there, and then you're going to put the compass here and you're going to draw an arc out here, and you're going to join that up to that. You're going to do exactly the same then from, let's say, this side here, or this angle here. So you draw an arc here from Z, and then what you do is you put your compass on this, let's say this point here, draw an arc, and then put your compass here, draw another arc from there, join that up to Z. But this is your incenter here, this is your incenter here. So when you bisect 2 or 3 angles in a triangle, the intersection of the 3 bisectors, or the 2 bisectors, will be your incenter. So as I say, I have done a video on this, so you can have a look at that. It'll be a lot more accurate than this. Okay, so that was that part of the question. Let's have a look at the next one. So part B, the diagram below shows the triangles ABC and ADE, not to scale. The triangle ADE is the image of the triangle ABC under enlargement. Some of the lengths are shown on the diagram. Use the length BC and DE to show that the scale factor is 3.5. Okay, so we have this triangle here, which is enlarged by a scale factor of 3.5, and it gives you this big triangle here, ADE. So the scale factor is 3.5, so what that does is it scales up lengths by 3.5. So in other words, if you multiply 4 by 3.5, you should get 14. They want us to prove that, or show that, the scale factor is 3.5. So what you would do there is just take 14 divided by 4, and that does in fact give you 3.5, which is our scale factor. So this is the length DE divided by the length BC. Okay, so that's that one. Let's go again. Part 2. AC is 6 units, and we can see that AC here is 6 units. Use the scale factor to find the distance from C to E, that is the distance from C to E. So we want to find the distance from here to here. So what I'm going to do is I'm going to multiply 6 by the scale factor, and that'll give me the length of the corresponding side on the image triangle. So if I multiply 6 by 3.5, in other words, I should get the distance from here to here, from A to E. All I've got to do then is subtract 6 from that, and that'll give me CE. So let's multiply 6 by 3.5 anyway. So I'm going to take 6, I'm going to multiply that by 3.5, and that'll give us 21 units. So that's the distance from A to E, which is not what we want. We want the distance from C to E. So the distance from C to E then is just going to be the 21 units minus 6. So that will give us 15 units. That's all you've got to do there. Okay, let's have a look at the last part then. The area of triangle ABC is 11 units squared. Find the area of the triangle ADE. So we're given ABC. We're told that this here is 11 units squared. We've got to work out the area of the image triangle AED. So what you've got to remember is if the scale factor is 3.5, that will increase the lengths by 3.5. You multiply 4, for example, by 3.5 to give you 14. But in terms of area, if you want to find the area of the triangle ADE, the image triangle, you've got to multiply 11 by 3.5 squared. So what we've got to do is take 11, we've got to multiply it by 3.5 squared. If you do that, you'll get 134.75 units squared, and that's equal to the area of triangle ADE. Okay, so that's it for this question. Okay, so let's move on to the next question. Question 7, the first of the long questions. A company was interested in investigating the fitness of its employees. The table below shows the heart rates of 10 employees measured before and after exercise. Their heart rates are measured in beats per minute. So that's the table there, complete the back-to-back stem and leaf plot below to show this information. 2 values are already filled in. Okay, so we've got to fill in this stem and leaf plot. Now you've got to make sure that you put these in order. So we have 60, we have 65, we have 67 and 68. Underneath that you've got 70, 76 and 77. And then let's see, we have 83, 88 and 89, and then on the right hand side we've got 71, 79, 81, 83, 87, 91, 102, 108, 113 and 118. So that's the stem and leaf plot filled in. Let's have a look at the questions here. The values for the heart rates after exercise are shown again below. Work out the mean and standard deviation of the heart rate after exercise. Give each answer correct to 1 decimal place. So there is a kind of a manual way of doing these, but it's probably best just to type the information into your calculator. Your calculator will do it for you. So you should find when you do that, the mean will